Hello and welcome back. So on this video, we're going to be talking about the grain solver and what I did there, as well as the instancer that basically all these little pieces and rocks that you see through the environment, how I instance this. So with that said, let's get started. Right, let's move out of the way, and then as you can see, this is the graph. It's not really that complicated at all. It's pretty straightforward, really. This is kind of like where the grains happens, and really we are not doing much of like anything complicated here. But let's get started here. So here basically I'm just loading the cache, right, where the disintegration happens. So if we look at this, you can see that it's animated and it's kind of like disintegrating. I'll explain this a little bit later. We have two streams here. The bottom is loading that, and the top stream is loading the terrain. So if we look at this now together, we have the terrain and the cache coming from here, right? Great. So then what I'm doing with the computer frame, basically I'm just freezing that frame if I need to go back to the beginning here. So basically I'm freezing on frame 1010 here. Oops. And then as you can see now, if I scroll through the timeline, there is no update on the animation, right? So that gets fed in a few places, but let's start here on the top. And that gets fed basically here. Let's start here first, sorry. So we get the freeze frame, and then I'm computing the bounds for this mesh. And if we look actually at both of them at the same time, you will see what's happening here. Basically, I'm just getting a sphere bound type, and then I give it some padding. You can also do like a box padding and then also pad that. In this case, I prefer this. I mean, this was like it works better for me. And then that get passed into the tag inside geometry, right? Then again, this is the geometry that is inputting is the terrain here. And I just extrude a little bit, like almost nothing, just to give it some extrusion. And then we are feeding the bounds into the bound geometry. So if we look at this now, you will see that basically I'm tagging this component, the face component, basically, right? Where whatever within the bounds of the sphere. So for example, if you wanted to make this bigger, you can actually just get the padding a little bit larger, and then you will be grouping more faces. In this case, this was enough for me. And just in case if you didn't know, let's say, I don't know if I talk about this in an early video, but we have this expand option here. So let's say that for whatever reason you are putting a geometry here instead of like the padding, right, that we're using in this case, you actually can expand this also procedurally here, which is actually nice. This is kind of like and you can go negative as well. So actually the expansion goes inwards, right? So you can actually do it like this. And this is useful as well to have actually in this node. And then the point, the group for this is point inside tag. That is the default. I didn't change it because I'm using the Boolean port to basically filter the faces here. And filtering the faces means that you can, and let me hide this. Filtering the faces is gonna do basically, it's just gonna delete whatever the selection is. So if we look at now this, basically I'm deleting everything that is outside the bounding, right? And remember, you can always change this on the fly here to make the selection bigger or not. So that's kind of like the beauty of kind of like the node system and working procedurally. So we have the filter faces, and then basically, let me just hide that. That goes into the mesh to volume, and then we are creating an SDF from this. There you go. So now we have an SDF, and if we look at the properties now, this is going to be a voxel sign distance, which is an SDF. By default, remember, this is going to give you a fog density here, and I just store the level set. The volume mode is solid, and I just change the resolution mode from relative to absolute, and then I lower the detail size so it's a little bit higher res. And then I added this a little bit of a mean hole radius. And what this option does, if you didn't know, let's say that I have a sphere here. Actually, let me just create it here real quick. And then let me bring this here. And if we look at this and just I delete, I don't know, a couple of faces here, I don't know, random faces, whatever, doesn't matter. Let's delete that. And then we bring this into Bifrost, for example. Let me just copy this. No, copy and paste. Let me actually turn on this and let me leave it by default. I believe the thickness is 1 by default here. So if we fit that into here, you will see that we're gonna have holes here, right? And usually it depends really what you're doing, but if you want to create like a watertight mesh, right, this wouldn't do it, right, because we have open faces. Obviously you can close this before you feed that into the volume, but this mesh to volume, actually all the volume, the convert to volume and the mesh to level set as well, they all have this option here, which basically if you're a little bit lazy, you can just close the holes automatically from the mesh to volumes instead of doing it in polygons, like right on the primitive itself. So this is a good way. I mean, this can work. Let's say that you have a huge database or like a huge model, right? And then you don't know where the holes are. You actually can use this, for example, just to create a watertight mesh if you need to. Okay, so let me delete this. Right, so let's move on. So let's go back now here in this part. So here again, I'm feeding actually now the frozen geometry. And then here what we're doing is we're using the attribute that we saved all the way back at the beginning, like the custom the point intersection tag that I set up with also with the geometry. Again, this is kind of like the default basically. So, and then I'm using a node called get component tag. And this basically what allow you to do is create getting tag properties, right? Or attributes or groups, whatever you want to call them. At the end, it's kind of just an attribute on the mesh. And then I can just get, and you can get the Boolean data or you can get the indices as well, right? So like what kind of like what IDs for these guys are. And then you can do other things if you found or what is the target, for example, and all that stuff. I just wanted to showcase this node because it's useful. Obviously, what we can do as well here is just kind of like type the property, as I said before. So we can do the same thing. So actually the graph is a little bit cleaner, right? So remember, auto ports, you can change the ports by right clicking and then changing this to a string, for example. Anyway, I'll keep it how it is. It's doing the same, but now I'm deleting basically what we were looking at before, right? So if I, again, bring this into here, now we have the intersection between the mesh and that, right? And then it's because also we're looking at this, the cache value. But now if I bypass, now I'm deleting exactly the bottom part, right? Cool. So then here I'm using a noise just to delete a few points. And let me just hide that. And let me go inside. Let me also change the viewport here so it's easy to see by just deleting faces randomly by the noise. So if I bypass this here, we can see the noise, just a black and white noise. I scale a little bit the field here, right? So you can see that that's gonna make it a little bit bigger or not. And then by default, this output an attribute called point color, and then I'm just grabbing the first because it's a black and white, so all the different X, Y, and Z is going to be the same value. I'm just grabbing the first one there, and basically I'm saying if this value, right, that is coming from the point color is less than 0.025, then delete all those points, basically all the dark places, most of that dark, right? And as you can see, this is actually, I mean, it's fine, right? But it's, and then what I'm doing here is just passing this into an SDF, and you can see that this data here, right, is not great. And usually you want to pass a little bit cleaner data, but you can see actually the mesh to volume does a decent job. I mean, this is actually pretty bad, to be honest, to give this data into a volume. It's open and it's all nasty. So again, Bifrost has some tools here on some that help you with this. Like for example, you can do shell or thinning, or sorry, on solid, The thing helped quite a bit. Without this, if I just lower this to 0.1 or 0.5, you can see, and actually let me hide. This is going to give you a very bad result from the mesh to volume, because again, the input is pretty bad. So just leaving the default. I think it's that the default. Let me just make sure that I'm speaking the truth here. Yeah. It's going to give you a pretty, okay result, depending really for what you're going to use this, obviously. And you will see very soon for what I'm using this. But for this actually for me works. And again, I went to absolute here and I changed the detail size, a lower detail size as well. And then again, we are storing a level set. I didn't transfer any properties in any of these two guys. So it's just this SDF passing along. And then I'm just merging both inputs. So if we look at this now here, we have like the bottom part and the top part. And as you can see now, we have a merge, and this is going to do a union between the two SDF. You can do also kind of like Boolean volume here if you need to. In this case, I just wanted to basically put that together. So we have now one SDF, right? And this is what is going to get fed into basically our grains here, the source npm sand. So let me do something quickly here. Let me go to the low res. And let me hide this for a second. And let's just look at the points here. Let me go back to my dark. So if we look at this, you will see that actually this is the input for the source npm. And that's why it really depends how you're using the volumes and what are you using for. For this, just to start my simulation where I want points or not, this was the case that I wanted to use. And basically, as you can see, we have this very kind of like where I want to put my simulation. Like basically I'm deciding, okay, I just want to simulate this area. Again, if we look at the, let me go back here real quick. If we look at the terrain, and actually it's going to be even simpler if we look through the camera here, you can see that I'm missing all this area here. And if we look at the video, right, I could easily done all these grains, but that would be a completely waste of resources, right, computational time. So basically I just decide to do what I need for the grains, and then the rest kind of matching, as closely, and then kind of unionize this, or like putting together the two different pieces. And you will see how I do that. I mean, again, it's nothing super complicated. And as I said before, this will be a good version to show supervisor and stuff like that. So basically I have my terrain, and then I have this exact, and this is going to be my starting point for the simulation for the grains. Okay, let's go back here very quickly because I want to talk about this here. I'll show you. So if we preview this, and let me turn off the grains here, I want to talk about this recompute on demand, or actually just more in general caching in Bifrost, basically, for time dependency and stuff like that, which I think is kind of important to know, so you can speed up basically when you work in the graph, really speed up your workflow in general. So if we look through this node, right, the compute on demand, that remember I talked in my early videos where to get this node from, and then I just set it as a compound, by the way, because it's so useful that I have it as a node now. Anyway, so if we look to the mesh to volume through after this, right, and if you look at me scrubbing here, there is no slowdown. You can see that's actually pretty much real time, right? Also from my FPS and all that. If I turn off this and I will look through the merge, which is the same, right? And just look down here in the timeline and just see when I try to scrub, I'm trying to scrub, and you can see how slow, and look at the FPS as well too, like the frames per second, how kind of like laggy this is, right? So that is basically what is happening here, is that we have this, remember that Bifrost is a graph executing all the time, and there's ways to catch the input so you can actually work faster. That is the way that, at least in this recording, the video, how the cache works in Bifrost, is just executing all the time. So when you have, for example, time dependency inputs, or or when you're doing some heavy operations, right? I mean, this is not really that complicated, but I mean, it still is kind of, you can slice through. I mean, it's a little bit of lag and stuff like that. But when you're doing some volume work, and you're doing something with large data sets of like millions of polygons and stuff like that, and you're trying to see, another frame, you say, why this is so slow? I'm not doing anything. It's not time dependent. There's no animated inputs, right? It's because it's executing. So, I mean, remember, there's a few ways, like what we did use here, like the computer frame, that can help, right? So if I copy this real quick, and let me go back to the beginning here real quick, paste this, and I'm just spending a little bit of time here because I feel like this is important. So we're computing basically this at this frame. We're telling Bifrost, okay, compute the data, the input, right, at this frame to pull on. But if I pull the data from this to this frame. So now, if I go back here, now you can see we have the same result that we're having with this, right? It's all fast and good. And since this is not animated, it doesn't really matter because that is a way to work. And then you can feed this into the source npm SAN, and this really, believe me, is going to speed up stuff. If your input is not animated, there is no point to start computing on every frame, right? So you want to do this. I mean, not all the time, not every node that you do, but when you're doing something heavy, do it. And why I like this, I mean, I like this better, this option better. I'm going to explain why in a second, but let's, so I remember this is pulling a frame, it's pulling this frame, the first one, right? So if I go back here, it's all good. As soon as I go back to 1010, it's going to be difficult to show this in action, but there's a little pause when I go back to the first frame that this is pulling, because it's, again, it's grabbing the data from that frame and then it's releasing that, or actually caching. So every time that I go back to 1010, it's going to be a little pause. I don't know if you noticed, you see, it's going to be that pause that's going to be recomputed, and then again it's cached. A way to get away, obviously, you can cache this data on 1010 and then move this a frame later, and then that will actually solve that, right? And then now I don't have a slowdown, as you can see here on the first frame. That's not ideal all the time, obviously. So the way that this works is different. This is good for, again, for freezing, nothing wrong with this, again, and then you can see that has this lab tool, so this might be changed in the future, but it's a good node. Now this, the way that it works, there is no really computing on any frame. It just grabs the data, and then it just takes a second to calculate the first time, and then I can go back to 1010. You can see there's no pauses here. Again, it's going to be difficult to see in the recording, but test it out yourself. But there's no pauses at all. There's just always, it's like super fast. And if my input, for example, is animated, I can always click, always recompute, and that's going to be recomputed on each frame. Now, I have a quick example here that I want to showcase, and this is very, very simple. But if we look this, I have a sphere here. Let me go back and let me see. I have this sphere, and again, nothing super complicated. I'm just deleting the face with time. If we look inside, it's very simple. Just grabbing the frame, then I have to do this subtraction because my timeline starts at 1010. I'm using the frame, obviously. And then I'm just deleting this by a sequence array. That's all. Anyway, that is not the point of this. I'm just deleting stuff, and then I'm going to just pre-compute. I just want to show you this because this is going to make more sense here. So let's say that your input is animated, and then you like this frame, 1090, right? And if you pull the data here, now that's going to freeze at that time, but you can see that it's not really it's not computing again. It's just going. But then if you want to just to recompute every frame, you just click that, and then now we are back to the animation. You see, and you can freeze frames with this too, and actually it's faster than this because it doesn't have to pull from that whatever frame. You just tell it, okay, don't recompute here, freeze that frame. The only thing that I don't have in this node that you don't know. So what frame is this, right? I mean, I don't know where I pulled that data from. So that will be something to add into this node, for example. So we have kind of like a buffer where we got that data. And that's why this is useful, because you can tell where that frame was pulled. So, I can probably edit this and then add that information there. But that is the main difference, and that's why I like actually this a lot better than the computer frame. It's a great note, really, and hopefully that's actually it should be added to the core in my opinion. But anyway, that is just my opinion. Anyway, I just wanted to explain that because really this is actually very, very useful and it's helpful. And you definitely should take into account when you're doing heavy stuff, just compute that data. Obviously, you can always write a cache, right? With a file cache or the write notes, and that's always going to be cached. So, I mean, there's ways to do that, but you don't want to cache all the time stuff. Like if you want to if it's a still or like something that you're working with, I mean, yeah, you don't want to catch that. Anyhow, I thought that I will give you that tip. So let's continue. All right, so let's talk about the grain now. I feel like I covered everything here that I needed to. Okay, so in the source npm sand, really, for the most part, it's just the defaults. Let's throw one here, so it's npm sand. I believe, yeah, the only thing that I changed, which I wedged a few things here. This wedge was for the frequency, and I believe that the one that I was happy with, it was 0.35, I believe. Yes, 0.5 the default. And then this is just the noise for the cohesion, basically, right? And basically what this does is just giving a little bit of, let me turn off this. Let's preview this with the. It's basically giving the grains a little bit of like kind of like so the grains they stick together a little bit more. So you can see that we have some a little bit more brighter parts and some places that are darker because of the noise, right? So the places that are darker basically like can more act like more like dry sand, and the places that like a little bit lighter, they're kind of like the clumps, like the sand stick together more, right? I just wanted to have that option there. So, and I just wedge a few parameters from this just to get, and I end up using like this, what you see right here, right now. I make it absolute, so it's positive, but I believe actually this node does that as well inside anyway, if you provide, because the values from this node is going to be -1 to 1. So I just say, okay, give me just positive values with the absolute value here node. You can do any of this, obviously. I just end up using this, and then I believe that I mean in the sans property, that's it. Beside the friction, right? On the particle display scale, the default is 1, and I believe the particle per voxel is 8. 1 and 8, yes. So I just changed this, and then this. The way that npm works, by the way, about the point size, the size or the scale of the each point is basically it's going to be dependent on the detail size of the whole simulation, and then also with this too. So if you read more again here, you can it's going to be basically what is the particle display scale is going to be a multiplier of the point size. And actually, if you, again, I would highly recommend reading this. This acts as a multiplier output of the point size, but this not affect the simulation. So again, this is going to be it's going to be to change the effective simulated size of the particle, use the detail size, because that is really the main factor. So the points are bigger or smaller. The more, obviously, the more particles, the higher resolution the sim is, the more points, the smaller the point is going to be, and you will see more. Then you have an option as well with the particle per voxel. This actually is kind of like adds more particles into, so it's going to be more easy to see if we go back here. But if I change now this to the default that is 8, you will see that we have less particles. And I feel like you cannot tell, but you can also go higher. And this is going to add particles. But so let's read actually this so I don't mis-explain. But basically, it's the average number of particles that should be seen into a voxel. And then basically larger values increase the number of similar particles, and you can add detail, right? So we are adding detail, but the difference is that the motion is computed from the voxelite volume. Therefore, this will leave the overall resolution of the motion the same. So hopefully that makes sense. So So kind of like a process, kind of like a mix between, you know, when you want to create when you want to create like higher res, it's going to be really depending on the detail size. That is the main factor for the point size and also for the quality of the simulation. But then you can play with this too, for example, for the display scale. If you want more, if you want the points to be bigger, for example, I can increase this, as you can see that now, make them quite bigger. Or if you want to add more points, but you kind of save a little bit on, so you don't, but you don't want to go higher on the resolution, you can do it through here. But again, it acts like balance, right? It's kind of like acting all as a multipliers, and it's just a combined equation that creates everything. So it's kind of playing with these values too to create something that you like best. All right, enough of that. Then I have a rest position here that I didn't end up using, but this is kind of cheap to compute. And then again, you know, rest is great for if you want to create for shading, basically, if you want to kind of colorize this or you want to add, for example, noise into the sand, but it doesn't jump around. You can create a rest position, and there's multiple ways, again, as I said before, to use this rest position. And it's I didn't end up using for the grains at the end of the day, but again, it's easy to compute and cheap. And you can use this kind of like the position field and the rest here for the particle solver, for NPM, for the flip and all that stuff, right? Or for any other actually things. Then let's move here down below. I have the collider, which is just the terrain. Now the same thing that we use in the smoke and particle solver. And then we have our good friend, the collide field influence, which is basically just the input, the load, I'm sorry, the cache, right? For the skull that is animated and disintegrating. And I put the friction to 0.5. I have some push out velocity here as well. And this is just my frame, so I can just change this if I want to change this later, but this is kind of like just my control over all these parameters. And then in the NPM solver settings, basically the default, we have gravity on, and I just lowered the settings for this because the defaults are 0.4, 1, and 1,000. So, you know, the time step size, the lower you go, the more computational expensive it's going to be. Obviously going to give you more and a more accurate and more better simulation. But again, it's balanced, right? What can you get away? Another little thing that you can actually get, let's say, a good way to also speed up your simulations with this guy right here. However, this really didn't make too much of a sense here because it's not like a huge sand or like an avalanche or something like that. If you're using snow, for example, this can really speed up because this is going to skip a few steps of collision. So it doesn't calculate on each frame. And actually, again, read the info, explain exactly what it does. In this case, I didn't use it, but you can use it in your own test when you're using other things. And then I have a grain bounce. And basically what this is doing, if we look at this, and let me get that, if we go from the top, basically this is going to be, what is going to be simulated is whatever is inside here. So this, whatever is outside is not going to get simulated. And this can also speed up your simulation. I was doing a few tests with low resolution, and the simulation never went, or it never really acted on this. So I just kind of say, okay, well, I'm gonna just make this area smaller where the simulation needs to happen, and I'm just saving a few you know, frames per second there. Another thing that you can do too, that remember all the source, they have this active attribute here that you can actually utilize. Like you can make some points active, or for example, if it's something is going to collide with something, you can make it active when collide. So before that, it's not simulated. So actually, this is pretty useful. Not for in this case, but again, for other things, you can use it. And remember too that all these properties that you see in the sand properties, you can manipulate all these parameters like dynamically, right? Doing simulation basically with different influences and stuff like that. Again, this was a very simple sim, so I didn't do any of that. I'm just trying to basically tell you what you can do. There's many things that you can do. And then we went out, so I cache it, and then I just delete whatever I didn't need to, and then we cache. I have two things here. I mean, this was just for testing because I'm not really rendering the grains from this graph. I render it separately, and we're going to be talking about this a little bit later, but I have the set point shape, the randomized rotation, and then basically if we look at this real quick here, you get that. And if I preview now, you can see that actually is pretty fast to preview this. It's like a 1 million points here. There's not really that much. But it's actually pretty quick, right? Now it's all catch and it's good and it's working. And let me just turn on the environment here so you can see that this is reacting. And actually, probably the skull too. I can turn on here too. So yeah, as you can see now it's working, and then I can preview this and it's working great. And that's it. Now I created an instance. I'm gonna explain this in a second. This point rotation, and by the way, this is just, you can change the representation here in the viewport to whatever you want. You can do a sphere, you can do cubes, and it's gonna be as fast. I did this obviously because I didn't want to look at the instance. I mean, let me show you real quick because it's actually it's a little bit slower because the pieces also are not just as simple as like a sphere or like a box. This is actually 30 pieces that I save in this one in a static cache. They're chatter, and I'll explain how I did this, and that's why you get kind of like that. Basically, you get these highlights here. It's not like as in all of these pieces are kind of like, it's not just spheres or boxes or any kind of simple primitive. It's a little bit more complex than that. I mean, nothing super complex, but it's just a chatter piece that I instance. I'm using the same rotation, and then I just set the point size here too. And again, I didn't use that, so I have this on because for previewing, this is a lot faster on the viewport. All right. So then if I go back here, this is just basically grabbing the terrain, nothing. I mean, this is just the terrain. The only thing that I did here, I just grab a fall off, and I can't remember why I did this, but I think it was just something that bothers me. And as you can see, it's just basically lowering this. So if I go back to 0, so it doesn't have any effect, that is like that. And then I just say, okay, just lower that. That's all. Then I blur this whole geometry and I computed the normals, and then that goes to render. And I'm rendering, for example, the terrain from here. That's why I have this here, just to remind myself. And let's talk about this part here for the rest. And actually, let me just show you here this. So this is the rest, but this is just a static, right? Because I mean, we are not really, this is not getting animated at all. So we are grabbing, let me go back and here. Man, actually I'm going to turn off just so I can explain this again. Let me turn off that again. I just want to show you that, and let me turn off this too. Okay. So basically I'm grabbing the data, the Boolean data from from this. So that is my Boolean data. I'm just passing the data up here. And basically I'm just saying delete faces, and the delete faces, what it's going to do is going to delete everything. And let me turn off this. So instead of the filter that deletes everything outside that, the delete is going to be the opposite. It's going to do the opposite. And let me turn off this. So now we're going to have a hole where the grains are. And I think now you can tell where I'm going with this. Then I have another tag inside geometry, which is basically just grouping. I'm grabbing these bound faces here, which basically, if I look through the camera, is what I see with the camera. And then I'll explain why I did this. And I at the end use, for example, like the cooling, the frustrum, right? A frustrum cooling, because you can do that as well with the camera. I'll explain why very quickly. I'm not going to go very into depth, but I'll leave it here for now. So I have that. So I created like a group. I inverted this because by default, it's going to give me whatever, where the bound is. So will give me this, but I want the invert because I used the delete faces. I could have done the same with the filter faces, but anyway, turn off that. As you can see, so I basically inverted. You can invert that. So now we're going to get this. And I think now you really know where I'm going, right? Basically, we're using this piece of geometry for creating the instances, right? Like the different instance, whatever where basically it's where the camera is. It's a little bit, we have kind of like you could call it an offset or, because if I show you the camera here real quick, that's what the camera sees, right? And we have more than that. And usually, even if I was doing this, I will give you, yeah, a frustum offset as well, because you don't want to cut exactly at the point right here, because you can get some time, depending what you instance, you might see things jumping in and out from there. So you want to always give an offset to that. Anyway, so I deleted the faces, then I computed, I compute a fog density here. That's going to be tough to see, but I think you can see it right there, right? Let me try to change now. And then I just scatter points on this, and I have 2 million points, I believe, in this. It's gonna take a little bit to compute. As you can see now, we're just computing outside that, without that, and then also the rest of the geometry here. And this, the max number of the scatter is 1 million points, and this is good to have. And then just change this to 2, because let's say that you're playing, just kind of dragging this, right? Because you can drag this, but you can go, it can crash if you're not careful. Let's say you go 10 millions or 1 billion points. Yeah, if you try to previsualize that, it's gonna crash. So this max number is always good to have. And then I decide to go to 2 million. I think by default, again, as I said, it's 1 million. Yeah, 1 million. So I increase that to 2 because that's what I wanted. So I'm scattering 2 million points here just randomly. I put the point size. I have the points from the grains, like the size. After I catch, obviously, my grain sim, I can check the point size from there, right? And then I have this. But I play with this a little bit, and then I went a little bit bigger. And then basically, I'm just recomputing on demand again. This, and then using the same random rotation that I use on the grains. And then I'm doing the same. So I have the set point shape here. And that is what you see in the final. So we have now this. And basically, as you can see here, everything is working. And if we look through here, you're never going to see kind of outside of this what the camera sees. Now, why I didn't use a frustum column here? Basically because I was a little bit lazy, because what you could have done is, remember, the camera is moving here, so I needed to run this into a solver, basically. Or there's other ways to do it without solver, but you need to get the path of the camera, like what is traveling, so you don't call stuff there like scattering, because those points will be jumping. So that's why I didn't use that. This was just an easy way, a very straightforward way, without doing a solver or other ways to do it. And then and I believe that's it. I mean, that's what I'm doing for all these, the grains. We talk about the these pieces right here, right? I'm scattering here, and you can see that it's not perfect by any means, right? But you can barely see in the final. I mean, you never see whatever the hole that we have there, because we have the mountains there. And again, this is for preview, like to show something to your supervisor. And I put some assets manually here just to kind of like, because if you really pay attention, you can kind of tell where the edge here is. And there's other ways to also hide this kind of like breaking of the simulation or not. And remember that this is not really a sphere, because here you will be able to tell a lot easier if they were just spheres. But since I'm scattering like these kind of shattered pieces, right, and they're all kind of randomized rotation, you can barely tell. And for those shattered pieces, it's basically down here. So I'll explain this now very quickly. And let me again hide everything here. Hide that. Hide this. I'm going to hide also the skull here. And let's go here. Okay. So if I look at this very quickly, it's just a sphere. Let me zoom in here. Very simple sphere. Then I created a density, so I can actually scatter points inside here. and then I scattered 30 points inside it. If you don't know this, if we look at the point scope here, and let me just do this. And let me just change the, oops, not this, sorry, color. So you can see that the points are inside, right, of the sphere. If I don't do a fog density here, and I just bypass that, that basically is going to scatter on the surface of this geo. But I want points inside the geo, so that's why I have this fog density, right? And as a solid, it's not shell, by the way, either, because the shell will do the kind of the same, because it's just taking the shell into account. So it needs to be a solid. And then I'm feeding the points, the positions into the center, and then these compounds, the chatter mesh and the post-process chatter mesh, are from the AWU, again, compounds. And again, that's why I said they're very, very useful. So I will highly recommend. And basically, I'm just feeding that, getting the mesh, and then what this is going to give us is just a scatter mesh, and or actually, I'm sorry, chatter mesh. So if I go back into this and we look at the wireframe here, you can see that this is kind of cutting. And if I look this, if we look to the exploded view, which is actually from ball, that's just basically pushing these points along their normal. You can see what it does. It's just creating these all these pieces inside here, right? And by doing this kind of density, you get also pieces inside. Then with this post-process, what it does is just basically, if it remesh, and then actually let me look at this here. But you can see it's remeshing, and then also it's applying a little bit of a noise. By default, this kind of remesh, and you can play with the remesh setting here. You can also subdivide this if you want to, and then have some displacement as well, a little bit, not crazy amount, but some displacement on these pieces, right? So kind of like it's not perfect. Yeah, it's not perfect flat spheres. Without this, you will see that this gets totally flat. With that, it kind of breaks a little bit. It's just a little bit more random, nothing too crazy. So these go together. So you feed the charts, and then you feed the original mesh, the sphere in this case, and then you can put a noise to displace this. And then it just reproject that to the surface. Basically, it's reprojecting to the original mesh, right? Then I just save a cache of this because I'm not animating, just one frame, right? Because I just need these pieces to scatter. And what you want to do when you're basically instancing, right, all these pieces, you don't want the pieces right here because the positions are not at the origin. And both of these nodes have an option at the bottom here to basically translate this to the origin. And this is really what you want to save. Because then the points, I mean, each piece is going to be at the origin 0, 0, and then you can scatter easily, and it's not going to be offset in space, if that makes sense. So if you look at the cache now here, it's just these pieces at this position. Then what I did here, I just grabbed that cache, I read the Bifrost object, and Bob is a Bifrost object, and then basically I just told the instance, read all these 30 pieces, right? From here, and then basically you say the selection mode is random, so it's going to randomize that selection. You can do it sequentially as well, or none. And yeah, and that's it. Again, you can change the amount of points here, how many pieces you want. I have 30 points, 30 pieces here, as you will see, but you can change this easily, and then I don't know, you can change to 45 or whatever, and now this is going to update. And then when you feed this into the instance, it's going to grab all those 45 pieces, and basically this mode, the mode is going to grab those 45 pieces and it's going to randomize them throughout your points, right, that you're feeding. And basically that's it for this graph. On the next video, we'll be talking about what I did with the post-sim render. Yeah, and that probably will be the final video for this series. Cheers.